So let's consider a building's water supply. So we've got a water main coming into a building here. And so we got a pipe that comes up here and then like a faucet. Okay. And let's say that the diameter here, D1, is 4 centimeters. And let's say the pressure in the water main is 9.7 times 10 to the fourth pascals. And let's say the water is flowing, well, let's say that we'll won't worry about the water, right there for right now. Okay. So, and up here we have a faucet, and the faucet is at a height here of 4 meters. Okay. And let's say that the diameter of the pipe up here is 3 centimeters. So R1 is going to be 2 centimeters and R2 is going to be equal to 1.5 centimeters. So first question is, what's the pressure up here? Okay. So we think about it and we say, okay, Bernoulli equation. So P1 plus 1/2 rho V1 squared plus rho G Y1 equals P2 plus 1/2 rho V2 squared plus rho G Y2. Okay, water's not flowing, so those terms are zero. Okay, we've put our origin at the bottom, and so P2 is going to be P1 minus rho G Y2. So P2 is going to be 9.7 times 10 to the fourth pascals minus density of water, 1,000 kilograms per cubic meter times 9.81 meter per second squared times 4 meters. And so P2 is going to be 5.8 times 10 to the fourth pascals. And so higher floors in a building second floor is going to have less water pressure than the first floor. Kind of makes sense. Okay. Now, let's say that what happens is that someone up here opens the faucet. And I now want to know what happens to the pressure. I now want to know what's P2. So as they open the faucet, water starts flowing in here at 2.1 meters per second. Okay. And so we need to figure out now what's V2. Okay. Well, we know that A1 V1 equals A2 V2. So pi R1 squared V1 equals pi R2 squared V2. So eat the pi's. Okay. And so V2 is going to be equal to R1 R1 squared V1 over R2 squared. Okay. And so that comes out to be 2 centimeter squared over 1.5 centimeters squared times 2.1 meters per second. So V2 is 3.73 meters per second. Now, so this thing now is coming out, and so now we know V2, okay, and we got P1 right here, and so we'll say, okay, so what is P2? Okay, so what's the pressure up there? Okay, and so what we'll do is we'll say, okay, so we want to find that, and so we know that P1 plus 1/2 rho V1 squared plus rho G Y1 equals P2 plus 1/2 rho V2 squared plus rho G Y2. Okay, and so put that height 0. So P2 is going to be equal to P1 plus 1/2 rho V1 squared minus 1/2 rho V2 squared minus rho GY2. Plug in all of that, and what you get is 5.3 times 10 to the 4th pascals. So you turn on the faucet, water starts flowing, and the pressure drops. Okay, and everybody's experienced that you're in the shower or something, and then someone else turns on the water, and the water starts flowing, and the pressure drops. Okay, and what's annoying is that the pressure drops often differently for hot water versus cold water. So that's an example here of the Bernoulli equation and how it would apply in this kind of a situation.